An alternative method to using a peroxy acid in making epoxides is to employ a bromohydrin. This is accessible by adding water and bromine to an alkene. Treatment of the bromohydrin with a strong base then gives the epoxide through an intramolecular substitution reaction. Addition of bromine to an alkene in the presence of a participating solvent proceeds via a cyclic bromonium ion intermediate that is then opened up in an anti-fashion to give the trans-bromohydrin. Deprotonation of the thus formed hydroxyl group with a strong base generates an alkoxide nucleophile which displaces bromine in an intramolecular process to give the epoxide. The first step, covered in the earlier chapter on addition to alkenes, sees bromine adding to the alkene to form a cyclic bromonium ion intermediate. This species avoids the alternative 6-electron carbocation. In the presence of a nucleophilic solvent, such as water, the next step involves the solvent opening up the bromonium ion. Attack occurs from the opposite face of the molecule to give, after loss of the extra proton to the solvent, the trans-bromohydrin. The alcohol thus formed has a pK of approximately 17, so it is easily deprotonated by a strong base such as hydride to give the corresponding alkoxide. Once the alkoxide is formed, it is strongly nucleophilic and aligned perfectly for an intramolecular displacement reaction. Since the bromohydrin was introduced with anti-stereochemistry, the alkoxide is able to deliver electron density into the antibond of the CBr bond and kick out the Br leaving group. This results in inversion of configuration at that stereocenter. The result is transfer of negative charge from the reactive oxygen to the more stable bromide, which results in the epoxide cycle. Overall, this two-operation process is therefore a useful alternative to the addition of a peroxy acid to an alkene. The bromohydrin is formed in the first step, and its anti-stereochemistry allows for an intramolecular displacement to afford the cyclic epoxide.